Hi, I'm Munir.
And I'm Sanchit.
And we are from Computer Science branch.
8th semester.
And today we'll be demonstrating a video on
Sumo
Sumo Simulator.
And Munir will give you a brief introduction about the simulator.
Hi. First, basically, before understanding what Sumo is, I'll give you the acronym for Sumo, that is Simulation of Urban Mobility. Now, traffic simulators facilitate the evaluation of infrastructure changes as well as policy changes before implementing them on the road. For example, the effectiveness of environmental zones or traffic light control algorithms can be tested and optimized in simulation before being deployed in the real world. So this is the reason why we use simulation. So now the Sumo is a free and open traffic simulation suite which is available since 2001. And Sumo allows modeling of intermodal traffic systems including road vehicles, public transport and pedestrians. Now included with Sumo is a wealth of supporting tools. These tools handle tasks such as route finding, visualization, network import, and emission calculation. Sumo can also be enhanced with custom models. You can customize the models and you can provide various APIs to remotely control the simulation. Now the features and applicability will be explained by Sanchit. Thank you.
The simulation platform Sumo offers many features. The first one is microscopic simulation, which includes vehicles, pedestrians, and public transport, which are modeled explicitly over here. The second is our online interaction, which controls the simulation with TRACL. Now the third part is our simulation of multimodal traffic. The examples are vehicles, public transport and pedestrians. The fourth one is time schedules of traffic lights can be imported or generated automatically by Sumo, which means that we can basically control the traffic lights in the Sumo simulator. Now the fifth point is no artificial limitations in network size and number of simulated vehicles. So we can import as many vehicles as we want to. The next point would be supported import formats are OpenStreetMap, which stands for OSM. Then we have Vism and Navtech. The last point in the features would be Sumo is implemented in C++ and uses only portable libraries. That would all be about features. Now applicability of Sumo would be Sumo has been used within several projects for answering a large variety of research questions, like evaluate the performance of traffic lights, including the evaluation of modern algorithms, with the evaluation of weekly timing plans. The next would be the vehicle route choice has been investigated, including the development of new methods, the evaluation of eco-aware routing based on populant emission, and investigations on network-wide influences of autonomous route choice. Then Sumo was used to provide traffic forecasts for authorities of the city of Cologne during the Pope's visit in 2005 and during the Soccer World Cup in 2006. So those are the major events in which the Sumo was basically used. Then the last point would be Sumo was used to support simulated in-vehicle telephony behavior for evaluating the performance of GSM-based traffic surveillance. Now there are multiple components which are in the Sumo package. The main is Sumo, which is the command line simulation. Then you have GUI simulation with a graphical user interface. Then we have NetConvert, that is the network importer. Then we have NetGen, that is abstract networks generator. Then we have OD2 trips, that is converter from OD matrices to trips. Then we have JDR router, routes generator based on turning ratios at interactions. Then we have DF router, which generates with the use of detector data. And the last is our MA router, that is the macroscopic user assignment based on capacity functions. Thank you. Now we're going to start with the installation part of our Sumo simulator. So the steps are, the first step is downloading the Sumo source file. So this is the link. Now you can copy this link to your browser. Now this is the link from where you can download our Sumo simulator. As you can see, it's been downloading. You should save the file. It's gonna take about just 8 seconds. Okay, after downloading our, you can check the downloads. This is our Sumo source file, which is Sumo source 0.12.3 tar.gz. Now you can go for the second step. Now this is our move editor, which we will be using later on to make our own scenarios in the Sumo simulator. Yeah. This is a Java file, hence .jar. Okay. Now here you have to enter your details. Okay, now you can click on the download button. Yeah, you can click on OK. Now you can see in our downloads that these two are our step 1 and step 2 of our installation procedure. So okay, so after downloading the two files, we have to execute a few commands in the terminal. So the first command is sudo apt get update. You have to enter the password. Just few seconds more. Okay, so after the first command is executed, You have to extract uh, the location where the files are downloaded. Okay, extract the location. Now you have to change the directory cd at the same location and click enter. Okay, after that you have to configure, which will do the compilation. This may take a little time. Yeah. Now we have to type make. This is a very huge process. Now this will install all the packages that is involved in the Sumo simulator. Just be patient. Uh, okay, so now we have to type make install. Okay, after this you can simply type sumo and then sumo slash GUI, which will open your Sumo graphical user interface. Now this is your interface, and we are done with the installation process. Thank you.
Okay, now after the installation, I'll just show you a quick small example on how we can use a simulator and what a simulator does. So we'll click open the terminal, and previously we had installed a move editor, that was a jar file. So I would run that first, which would help us use the Sumo, create a scenario in Sumo Simulator. So first we'll have to change the directory to where the file is downloaded, and then we'll have to type this command for it to execute. Okay, so this is the move editor. Now here I would select mobility model. Now this editor would has various options for us to create our scenario, where we have the map editor, which will help us create the map. Then we have the vehicle editor, which will which will help us create the vehicle movement and the route. So first, with the basic, we'll go click on node. As you can see, we have an ID, X, Y, and traffic light if you want a yes or no. So we can add our files. So I'll open. So this is one previously file which we had created. So as you can see in this, we have different IDs. These are basically the names for IDs. That's node 1, node 2, 3, 4, 5. And this is the X and Y coordinates of the nodes. And this is an option where we can select if you want a traffic light or not. So I'll click on save, and then I'll close this. And the next step would be for the edges. Once you define the nodes, we'll have to define the edge, the path from one node to another node. That is basically the roads in our scenario. So here we have an ID from node to node, the type. Now using types, we can ignore the number of lanes, speed, and priority. That's another thing. So let's see how we can. So I'll open a file which we had created. So basically these are the IDs which says defines the type of road. That is, U will indicate upstream, D would indicate downstream, R would indicate right, and L would indicate left. So R12 would be right from node 1 to node 2, as you can see, from node 1 to node 2. So type, we have left it empty, and number of lanes we have set all default, that is 2, number of lanes 2, and speed we have kept 40, and for all the cars we have kept priority as 75. Now I would save this, and then I would close it. Now after the node, defining node and edge, we have an optional road type, edge type, which we would not require for this. So let's go for the configuration part. Now we had created two files basically. One was a node that is a .nod.xml file, and we had created the edge, that is a .edg.xml file. Now I would open these two files, that is this which we just saw, and the .edg.xml file, and now I would set an output file that would be in .net XML. Now I would like to save this in the same folder, trial. So I would give it the name trial.net.xml. I would create, then I'll click on save. It should then create a .netc.cfg file. So I'll save this. Now after this, after we have created the map, we'll have to look into the vehicles in our scenario. So for this, first I'll click on the flow, which will be the vehicle flow definition. Now here we have ID, which is in describer. Then we have from edge to edge. then the begin time, end time, and the number of vehicles. So let's look into the okay, so this is another previous scenario which we had created. So this is ID F0 and F1. So this is from edge R5 from right. It will move right from node 5 to node 0 to right side towards from node 1 to node 2. Begin time is 0 and end time is 1000. This is a default, and number of vehicles for F0 is 5 and for F1 is 2. Now I would save this and I'll close it. Now, after defining the flow, we'll have to define the turns. That is basically the probability of directions on each junction, how it would turn and where it would turn. Okay, so to define this, we'll have begin, end, from edge, to edge, and percentage. That percentage will define the ratio of how it will turn. So the higher the percentage, the more clear cut it will take. So now we open. So this is 0, and that is a basic default begin and end time. So from edge we have defined the various turns in our scenario, R5 not R, and the percentage is 75, which I kept 75 for all. So I would say this again. Now there's another optional option we have, that is trip for each vehicle type. How many trips would it take? So which we would not consider right now. So now we'll have to create the vehicle. Now to create the vehicle again, we had created 2 files before. One was a flow and one was a turn file. So now we'll open these 2 files. So I'll open a flow.xml and turn.xml. Okay. Then I would set and also now these 2 files are supposed to be integrated with the map we created before. So I'll open the map file as well. And then I'd set an output file which will be a .rou, which is the root file. So I would name it trial, and I would create it. Then I would click on OK, and then I'll close it. Now we'll have to visualize the whole scenario. So configuration. Okay, now yeah, before visualizing, we'll have to configure the whole scenario, where we would integrate the .NET file and the root file. So basically integrating the map and the root. And we would set an output file, which would be a .sumo.tr file. Create file, save, which would give us a sumo.cfg file. I'm saving this. Now to visualize the whole scenario, click on visualize file. Now so basically the move editor opened Sumo simulator for us. So now I'll click on file, open simulation, and I would set this to real world. Okay, so basically this is the scenario. As you can see, we have red, we have signals here. This is the entry and exit point. As you can see, we have arrow marks as well, where from here it can take a left, from here it can take a right, and from here it can take a U-turn. So basically these paths are defined everywhere. Okay. So now I would set the delay to 100, and I would click on play. So as you can see, we have 2 cars here, which is giving a left indication, so it went left. This is how the scenario, and 2 vehicles have entered till now, and the red. Now this is the 3rd vehicle. So as you can see, this is a very small example of the scenario, which tells us a Vanet simulation of how we can simulate a traffic by increasing. Now we can increase the traffic by increasing number of nodes, that is the number of vehicles here. So this is the small example demonstrating our tool Sumo simulator. So I'll stop the simulation here, and yeah, that's it.
As you saw in the previous segment, we created our own scenarios. We can also take the real-time maps from the website OpenStreetMaps. So yeah, this is the link from where you can download the real-time maps. Now Sumo supports this website, which is the OpenStreetMap.org. Now this is a real-time map of the Makery Circle in Bangalore. Now to export this, we can click on export. Yeah. So yeah, you can click on export. Yeah, you can save the file. Now this is getting downloaded. Now we can go to the downloads folder in Sumo. Okay. uh, Map.osm is our file. Okay, this is the code part of the map, which we have directly downloaded from the OSM website. Yeah, this is lat and long, the latitude and longitude. Now this is all real time. Now you can open the Sumo GUI. Now we have to open the, yeah, this hmm, this is the Makery Circle map, which is in a .net.xml format. Now click on OK to open that. Yeah, now this is our Makery Circle map which I have downloaded. Now you can just see, like if you zoom in, you can see the huh. Yeah, if you zoom in, you can see the signals, which is already inbuilt signals. Now these are the lanes. Yeah, so this is the basic idea of our Sumo simulator. So we can add any real-time maps, like suppose of if you want to add a map of London, you can add that also. You can make changes to this, you can add vehicles to this, you can run simulation on this. And as you saw in the previous segment where we created the our own scenarios, that is basically if you want to test any new idea or something like that, you can use our own scenarios for that. Okay, thank you. Now the coding part of our Sumo simulator is like this. These are all the files which we created using the move editor. Now, for example, if we open the .NET XML file, yeah, we can open this while in the text editor. This is the our basic code. Now you can see as the lanes start over here. This is our particular lane ID N001 depart max speed length, which we have defined in the, if you remember, in the move editor. Now we have closed the lanes over here, then we have defined each edge. So all this is in our net.xml file. Now if you go to the trial.route xml file, here we decide the route which is taken by the vehicle. Like suppose see, this is our routes where we define the vehicle ID. So we gave in our demo we gave like 5 vehicles. So we have vehicle ID 0 to 5. Yeah, we can, the vehicles are the vehicle. Yeah, the route edges goes from R50 U01 R12 D24 L. This is the entire path which is taken by our vehicle ID F0 underscore 0. Okay, now we have the main file, that is the trial.sumo.dir file. Now, yeah, here we combine each and every, we combine the previous two files, and this is the main output file which we run in the Sumo GUI. Now, um, now we can also check the performance of our each scenario. You can for doing that, you can open the move editor. In this you can click on the run simulation part. Like suppose for our demo, uh, yeah, this is the trial we have created. Now we can check the performance of this by opening this. Okay, now we have yeah, click on OK. Now these are the steps which is taken by the vehicles. Now, yeah, this, as you can see, we have the entire summary over here. The duration is 109 milliseconds. The real time factor UPS. Now the vehicles, the number of vehicles emitted and running, and the simulation end time. So this is basically to check the performance of our scenario. Thank you so much.